Hi, we're the Kronoscope team, and these are our winter quarter prototypes. The objective of our prototypes was to demonstrate the feasibility of our proposed design. Due to this project requiring both mechanical and electrical components, these prototypes focused on testing the main parts of each system. For a mechanical system prototype, we constructed a replica of our autoclave's lid to attach our selected motors to and test our proposed design. When the button is pressed, the cam lock disengages, allowing the lid mechanism to swing the door open. The lid stops when the top limit switch is pressed, pauses to allow the part to be inserted into the autoclave chamber, and continues to close the lid. The cam lock then re-engages, securing the lid shut. For our electrical system prototype, we began with testing our ability to communicate between an Arduino and Raspberry Pi through serial communication. Here we have a couple LEDs and push buttons connected to our Arduino, which is then connected to a Raspberry Pi. When either push button is pressed, the Arduino sends a one-line message to the Raspberry Pi containing the states of both buttons. The Raspberry Pi then reads the data in the message and sends back a message telling the Arduino which LEDs to turn on and off. For our final prototype, we recreated a simplified version of how we will be controlling the heating element of our autoclave using the same serial communication method. So here we have a buzzer to represent if the heating element should be on or off, a temperature sensor, a pressure sensor, a red LED to signal if the temperature is too high and the buzzer should be turned off, a yellow LED to signal if the pressure is too high and the heating element should turn off, and a emergency stop push button that'll send an interrupt signal to the Arduino telling it to disengage the heating element. So if I push it, it'll re-engage the heating element. And then if the temperature goes up, then the red LED comes on and the buzzer turns off, saying that the heater is turning off. And then if we let that cool for a second, then the LED warning light turns off and the buzzer turns back on. And same thing with the pressure sensor. If the pressure gets too high, then it warns you and turns off the buzzer. And as the pressure goes back down, then the buzzer comes back on. And then you can disengage the buzzer and the heating element by pushing the button. Oops.